Good afternoon. Welcome. Thanks for being here. We're so thrilled to have everyone. For those of you who don't know who I am, my name is Whitney Schubert. I work for Polaner Selections. I have the great pleasure of managing the French portfolio, working with the group of French growers for Polaner. For 20 years, I think we can say comfortably, Polaner has had the honor of working with practitioners of sustainable viticulture in all its iterations, growers who are making wines that are both nutritious and delicious. And regenerative agriculture, which we will explore today, is a growing movement that builds upon the influential work of those seminal growers in their bold elimination of chemicals, in the vital observations they've made about working in tandem with nature, and really in the way that they've helped to shape the ever-evolving conversation about what is good for Mother Earth and what is good for our bodies. Today we have the opportunity to learn a number of concepts that may seem, for some of us, new and innovative, but they are really based on an ancient blueprint. And it's a blueprint that predates human existence. We didn't invent regenerative agriculture, we just gave it a name. So we're here to learn from a group of individuals who have looked for and found answers in nature, answers that show real promise for curbing the devastating and worsening effects of climate change and for creating a healthier future. My mind has been blown wide open by these panelists, and I'm really delighted for everyone to have the opportunity to hear their stories today. So with that, it is my honor to introduce the panelists. On your left is my dear friend Mimi Casteel of Hopewell Wine in Oregon's Eola Amity Hills. Mimi was the first person to open my eyes to the practices and powers of regenerative agriculture. She's been crusading for a regenerative revolution and against the use of glyphosate for nearly a decade, and in many cases putting her reputation on the line for greater causes. And next to her is our moderator, David Wallace-Wells, who is a national fellow at the New America Foundation, a columnist and deputy editor at New York Magazine, and New York Times bestselling author of The Uninhabitable Earth, Life After Warming, which you're all aware now, after some prodding, that it will be available for purchase after the seminar, and Dave will be on hand to sign copies. He is a passionate researcher, a brilliant storyteller, and a valued friend. François Chidaine of Montluy-sur-Loire in the Loire Valley, a pioneer of natural viticulture whose awakening around saving his soils led him to a regenerative solution. His pensive, perceptive approach in the vineyard has influenced a generation of wine growers. Douglas Polaner, owner of Polaner Selections and longtime advocate for wine growers, who will be translating today for François, and whose openness and curiosity, along with his wife and Polaner co-owner Tina Fisher, is much of why we're here today. And Russ Konzer, on my right, founder of Standard Soil and chairman of the GrassFed Exchange, who experienced a transformation from a 30-year employee of Shell Oil Company, where they are taking carbon out of the ground, to an advocate for putting carbon back to work in the soils, especially in America's grasslands. Before I pass it off to David, just a few housekeeping things. Please make sure your cell phones are turned off, and please enjoy yourselves. Thank you very much. Dave?
Yeah, so thank you all for coming. Thanks, Whitney, for organizing the event. Thanks for the support of Polaner and I guess the Green Space. First, I just want to say I'm thrilled and honored and mostly humbled to be up on the stage with all of you. I am such a novice, a newbie in this world. I've been working on climate change for a couple years, but is not at all a lifetime commitment of mine. And The last few years have put me into contact with many more people who are many more deeply committed to these causes than I've ever been, and I'm always amazed to learn what they know from that. Some of those people are activists, some of those are policy people, some of those have been, working that knowledge into the ground with their hands over a generation, and I'm just, feel like an interloper. But Whitney asked me to give, before we get into like the real dirt level discussion that we're going to have later, a kind of bigger picture bird's eye view, and talk a little bit about how I see the story of climate change generally. And that's another area where I feel very much an unusual person to be speaking. I'm not an environmentalist. I grew up in New York City. I've lived my whole life here. And I felt for a really long time that the city was a protection against the forces of nature, and that modern life was basically the same. That climate change was something to be concerned about, to hope for policy action to address, but that I was going to live and everyone I knew was going to live protected from the forces of nature. And the last couple of years I've spent researching this world makes me know just how totally wrong I was about that. I came to think of that sort of big picture delusion as having three components. One of which is about the speed of change. I was really raised to think that climate change was quite slow. I think many of us were. James Hansen, who's one of the most outspoken climate scientists, his main book for a general audience is called Storms of My Grandchildren. We thought that the impacts were going to be coming at the end of the century or maybe in future centuries. But half of all the emissions we've put into the atmosphere in the entire history of humanity have come in the last 30 years, which is since Al Gore published his first book on warming. It's since the UN put together their IPCC panel on climate change. And that means that we've done as much damage to the future of the planet knowingly as we ever managed in ignorance, which I think is an incredible indictment of us and a concerning fact going forward. That's the speed of change. There's also the scope. I thought, crazily, I live in New York. I didn't even really understand until I started working on this that New York is actually on the coast. But I thought that I heard so much about Arctic ice melt and sea level rise that I thought, oh, well, if you don't live on the coast, then you're going to be okay. Climate change isn't going to come for you. But the more I learned about economic impacts, which threaten global GDP reduction as big as 30% by the end of the century, which is an impact that's twice as big as the Great Depression, or on conflict where war could double by the force of warming, agriculture, which we're going to talk about in some depth. I just started to see this was not a threat that could be compartmentalized. It was total, all-encompassing, and while it was going to hit certain areas and certain people more intensely, there was nowhere you could be, no person you could be, no matter what country you're from, no matter how rich you are, that would be unaffected by these forces. And then the sort of third misunderstanding that I had, at least, was about the severity of warming. And that is, I heard a lot about this threshold 2 degrees of warming that the scientists call threshold of catastrophe. And they would always say, we need to do everything we can to avoid this amount of warming. I think lay readers like me, therefore thought of that amount of warming as a kind of a worst case scenario. But in fact, practically speaking, I think it's about a best case scenario. Technically, we could avoid it, but it's going to be hard to. And that means that there had been very little focus, very little conversation about all the things that were possible north of 2 degrees, which are really quite horrifying. And when you start thinking about those impacts at 4 degrees, which is where we're on track for at the end of the century, the world starts to look functionally unlivable from the vantage of today. I mentioned the economic impacts. We'd have climate damages as much as $600 trillion, which is twice as much as all the wealth that exists in the world today. Places on the planet that could be hit by 6 climate-driven natural disasters at once. And you go down the line, and there are those kinds of impacts everywhere you look. But the truth is, those scenarios will only be brought into being if we bring them into being. The main driver of this whole story is what we do. That's the good news. It's kind of perverse good news. But when you hear about 200 million, maybe 1 billion climate refugees, when you hear about flooding, wildfires getting twice or 4 times as bad in California just by the middle of the century, these can feel horrifying. They can feel paralyzing. There's such intense impacts. And you think, how could we possibly live in those worlds. But first of all, probably we will find a way to live in them. Secondly, I think more importantly, they're a reflection of how much power we have over the system and how much we can do if we make the right choices going forward. And, climate change is an incredibly big problem. It won't be solved with any silver bullet solution. But in every sector, there are solutions available. We hear a lot about energy, renewables, and dirty energy. That's dominated, I think, the public understanding of where we are and what the future is. But energy is just, it's about 35% of global emissions. And agriculture, which we're going to talk about in depth today, is really just as important and in certain ways a bigger challenge, because we have at scale the substitute sources of green energy. And while we know, as we'll talk about later, many of the techniques that could be used to make agriculture work in the same way, we're much less far along in putting them into practice at the level that we need to. So even though, I'm sure some people in the room know this material quite well, others less well, the world as a whole is totally ignorant about even that agriculture is a problem for climate change, and certainly how agriculture can also be a solution to the problem. So that's sort of I walk in and I'm excited to hear all of you talking about these issues, because I need to learn more about those stories, as do we all. So yeah, Mimi, do you want to maybe start and walk us through how you see everything?
We'll stick to agriculture. So first of all, before I get started, I just want to say thank you all for being here. And more than anything, thank you to Doug and Tina and Whitney and the amazing Polaner team. I don't think I've ever had a partner in the wine industry that would have taken this kind of, I don't want to say risk, I don't want anybody to leave the room, but to present to a largely wine audience this material without the carrot of wine being served. And I think that it's a testament to their values and actually living the way that they believe that we're up here today. And I also just want to say what an honor it is to be with these people, all of whom are personal heroes of mine. So we'll get started. And I usually walk around and gesture a lot when I'm talking, but because I have notes and I'm trapped, I can never get out again. I'm going to do this way, but I worry about people falling asleep, so I'll try to keep the pace appropriate. So Thomas Edison famously said, "I have not failed, I've merely found the 10,000 ways that don't work," and that very much resonates with my own path here. I feel like I've had a very circuitous path back to agriculture. I grew up where what you're looking at here, this is my family's vineyard in Oregon, Bethel Heights, and that was when people were first getting a foothold in Oregon, and so our vineyard was put into wild nature, and parenting was more of a hobby then, more of a suggestion than an actual rule. And so I was raised by my surroundings, and very much that imprinted on me more even than my human relationships, which explains a lot. And I think that, that obsession with wild nature as I became more aware of the world around me is what led me into my sort of educational path, which was biology, microbiology, and ecology. And I started as a forest firefighter in undergrad, and then I went on to work for the Forest Service as a biologist. And that was when I had my first epiphany about the ways that I was doing it wrong, because we were fighting fires that even in the early 2000s, we had no chance of containment before that fire wanted to be contained. On landscapes that would have historically burned far more regularly, we were putting lives in danger for no reason, spending billions of dollars, and that's dwarfed by what we're doing now. And even then, it was clear to me that we were doing it wrong. And the other epiphany that I had working as a biologist in the wildlands was that they were all our setbacks, the beautiful parks and the beautiful national forests that we all enjoy, or hopefully you enjoy them. Those are eroding from the outside in. The pieces of the functional layers of those ecosystems are stretched so tightly now because they lack the support of the privately held land base that is so much more vast. With more than half of the ice-free land in the world under agriculture, I was just on the wrong battlefield. So that's what brought me back to agriculture and to wine, which I had very much missed. It was foundational to what I think about food and what I think about community and how community is built around the foods of a region. And that was my path back to agriculture. And in my absence, the viticulture in Oregon had also changed a lot, mostly moved towards more mechanization and more technologically and sort of the reductionist things that people learn about growing one crop when you learn farming in school has nothing to do with the way systems function. It's about getting the most out of one crop for a finite period of time. So, if you were to jot down, the 5 most dangerous threats to humanity right now, there's a good chance that there would be a lot of overlap in this room. The things that David speaks to so poignantly in his book, the war, the famine, the drought, the fact that we're going to have only more people flooding towards these places that still seem productive. And those things all have common ground, literally. But most people don't connect that to the vastness of farming and farming as a problem in itself. So the problem of agriculture, if you will. But global food production has already doubled since 1960. And projections based on world population growth suggest that just in the next 50 years, so in the next 5 decades, terrestrial biomes are going to have to produce as much food as has already been produced in the entire history of humankind. We are so programmed now to think about how to grow calories that we've stopped growing food. Meanwhile, in less than 2 centuries, many of the world's most productive agricultural soils have lost between 50 and 80% of their organic carbon, adding billions of tons of carbon dioxide to the atmosphere. Every ton of carbon in the soil, it's not an even Steven, equals 3.67 tons of carbon dioxide in the atmosphere. And meanwhile, in spite of the promises of technology and, chemistry, put forth by industry, global dependence on agricultural inputs continues to increase at a staggering rate. These things aren't going down. Inputs are going up, production is going down, and the value in that food is actually almost nothing. And to top it all off, agriculture is now second only to energy production in the production of greenhouse gases. So we pat ourselves on the back a lot for increasing the sustainability of our agricultural systems, but it's a house of cards that's built on air. We are literally losing ground, and yet we fatalistically continue to do things the same way. And I think that this is a good time for me to say that there is nothing in me, and I don't think there's anything in anyone on this panel that would put this on the backs of the farmers. Farmers respond very quickly to the demands of the people that they think that they're feeding. So this is not about attacking farmers. This is about awakening. This is about supporting a new way forward. And I really want to drive that home as much as I can. So we're standing at the edge of an abyss, and yet there is so much hope tied up in these landscapes. Really so much of the answer is what we're standing on, and it's complicated, but it's beautifully savable. So that's the main message of today. And if we're going to do this right, the climate change that we actually need is a climate change of the mind. We have to completely change the way that we think about the agricultural landscape. All right. So this may seem a little divergent, but how do we begin? And even in the beginning of a new solar system, time, along with the laws of thermodynamics, dictate whether or not a planet can support life. in the immense heat of a dying star where atoms are disassociating, helium fusion produces carbon. And once carbon is made available, nitrogen and oxygen follow in what's called the carbon-nitrogen-oxygen cycle. And I point this out just because those physical laws are undisputed. And the application of those physical laws through a biological cycling is what we have completely interrupted with agriculture. So before life was present on Earth, and that took a while, it was really hot here, those elements were cycled physically and chemically. But as soon as life happened, and it's probably a lot sooner than many of us in this room have even ever thought about, but I'm fascinated by it. All of those cycles were driven so much faster through biology. And those are the processes that are both elegant and designed by evolution that we have just sat upon with everything that we do. The turning point for life on Earth really happened with photosynthesis, which was also much earlier, I think, than most of us realize. And that stripping of electrons from water and forcing them onto an abundant gas, carbon dioxide, to form sugars and free oxygen. I mean, if we could just focus everything that we have on photosynthesis, a lot of the work is done right there. So the idea that I'm trying to get across is that the robust capacity to cycle these nutrients happens only with life, because life makes these things happen in real time. And luckily, it happens for free around us all the time. So the truth is that all of these cycles are inextricably linked. The carbon cycle, the water cycle, the nitrogen cycle. The coevolution of Earth and life on Earth made the act of living part of cycling these biogenic elements. Life literally pumping water into interior landscapes, cycling carbon as it went along. Those cycles would, if we were all to just disappear, if what's it called? The awakening, what is it? The rapture, thank you, I'm sorry. I just, forgot that word for a minute. If the rapture were to happen, these landscapes are already starting to try to repair themselves. And we just go about stopping the repair cycle every time we go and do something. So the problem of agriculture is that our current systems interrupt all of these cycles. And that's part of the beauty of this message, is that the hope is in just remembering these cycles want to happen without us. So the power to change is photosynthesis. It is the most brilliant and elegant invention of evolution, in my opinion. The act of photosynthetic organisms using light energy, free light energy, to strip electrons from water, releasing oxygen into the atmosphere, and then producing carbohydrates to support further life. So that's the equation we all had to learn in school, and it's really the way that agriculture can move back. More than 95% of life on terrestrial Earth, so more than 95% of the life that is on a terrestrial biome resides in the soil. And most of the energy that drives that life comes from plant carbon. Without that life, there is no soil, because what you have then is just the weathered remains of parent material. That's what we call mineral soil, and that is not biological soil. We're taught that plants feed themselves through photosynthesis, but the fact is you can get carbon, hydrogen, and oxygen that way. Everything else that a plant needs, the 17 to 21 nutrients that a plant needs to grow itself and make nutritious food, has to come from another source, and that's the soil. And in fact, plants take much of the sugars that they produce in photosynthesis and send them directly into the soil. And why would they do that? And it's to feed microorganisms. Those co-evolved relationships are the foundations of the possibility of the further radiation of complex life, the capacity to drive cycles in real time. Mycorrhizal fungi, bacteria, rotifers, all the special little things that live in the soil, they are 100% dependent on plant carbon. So if you think about the fact that most of agricultural land is bare now for at least half the year, where are they getting their food? They're not. And when they can't be fed, they disappear. And nature doesn't like negative space. And the things that tend to fill that negative space tend to be antibiotic-resistant bacteria that can grow on anything. But lifeless soil tends to be at the sort of devastation of our positive microorganisms. And that association of microorganisms is very much analogous to our own microbiome. And we are just now beginning to realize the laundry list of postmodern diseases that are related to failures in our microbiome and the communication between our gut and our higher function. It's the same thing for plants. Plants cannot grow nutritious food without microorganisms and a healthy functioning system below the ground. And that is very broken right now. So we're gonna watch a quick video. I know this seems strange, but basically this is a video produced by NASA that shows a year in the life of carbon dioxide on the planet. And so the scale of color that you see, and the reds and yellows especially turning purple very soon. So this is January. You can see the month at the bottom of the screen. So the red and the yellow that you see right now are the carbon dioxide coming from the northern hemisphere. And essentially, this video points to the power that we're standing on, the hidden answer that we're just standing on and throwing our hands in the air and looking for a technological answer, like a magical vacuum that can suck carbon dioxide. So you can see as it turns purple, this is a very powerful point in the video. So this is what, January, February, March, April. And very soon you're going to start to see a major shift, and that speaks to the power of photosynthesis. Soil is our largest potential tool in the fight against climate change. It is our greatest hope. It could be the largest potential carbon sink, and most of the soils in the world right now are a carbon source, a net carbon source. So we're moving into the growing season, and you can see how quickly photosynthesis is drawing down atmospheric levels of carbon dioxide. This is just after we reach 400 parts per million in a year cycle. We start drawing that down very rapidly. And this is growing monocultures. So you can imagine that if we were to harness the power of photosynthesis and really use it to our benefit, we could actually interrupt the production of greenhouse gases from the combustion of fossil fuels, basically. We almost bring that down to zero. And what you're seeing right now in the grayscale in the southern hemisphere is the wildfire contribution of carbon monoxide. And arguably, those problems become less bad when we start applying an ecological structure to the agricultural landscape. Devastating wildfires are, again, part of our own doing. And much of getting us the way there lies just in that process of photosynthesis. So what you're going to see now, and even NASA, when they narrate this video, not me, says that this is because photosynthesis goes down as we move into the winter months in the northern hemisphere. But in fact, we're plowing right now. And we are relying exclusively on the sort of aerobic decomposition of our plant residues and then releasing all of that right back into the atmosphere when it could be stored in the soil. So if we could go back to the slides, thank you. Modeling using remote sensing data of global patterns of cropland use do suggest that just an increase of 5% in global photosynthetic capacity or photosynthetic rate, and Russ has good data on this as well, would be sufficient to counter the carbon dioxide flux from the burning of fossil fuels, provided that we store that carbon deeper in the soil, so beyond that ephemeral source of carbon that gets reoxidized as we decompose and plow our soils. Everybody awake? So At the species level, plants have different photosynthetic rates and different photosynthetic capacities, but they also each support their own suite of microorganisms, and they have co-evolved to depend on one another. So the humification of carbon, so this is the process that actually takes carbon from, an ephemeral form and turns it into a stable form. Carbon is unique for a reason. It's tetravalent, so it can form 4 unique bonds, and that allows it to form chains that are very, very long and can be very, very stable. There's a reason why it's the building block of life. So the carbon that we currently sort of work with in the agricultural arena has a fate of being reoxidized because it's not being humified. But just to take the example of mycorrhizal fungi, does everybody know what those are? Do you raise your hand if you don't know what that is? Okay, so mycorrhizal fungi are especially associated with plants. They are an organism that creates a beautiful corset of hyphae, which is a fungal structure around the roots of plants. And this is an ancient system. And they basically are fed plant carbon through photosynthesis, and they use that plant carbon to form complex molecules with inorganic forms of things like phosphorus, it's especially important to grapes, and make that available to the plant because the plant can't access that on its own. So that relationship has evolved specifically so that these organisms can feed themselves by feeding each other. And if you think about it, if you try to grow a grapevine without phosphorus, you are cutting one of your legs out from underneath you. And the same is true of any agricultural commodity. So any food that you eat has a microorganism that it's completely dependent on. And so as soon as photosynthesis starts feeding those organisms, the mycorrhizal fungi and the bacteria that are in that root zone, that gets channeled directly into the soil as soluble carbon, but it's still not stable carbon. In the deeper layers, it gets handed off in this kind of bucket brigade with other microorganisms that attach it to minerals and nitrogen, forming longer and longer and longer and more stable chains, and driving it deeper into the layers of soil where it can be stored almost permanently. Those are the banks that we have been depleting. And those humic compounds are completely stable. They sequester more gas that way. They also increase water holding capacity and soil tilth. So if a political movement were to help in this transition, it would be to take proceeds from carbon taxation, if you will, and support farmers in converting conventional agriculture towards a more sustainable, a truly sustainable, and I hate using that word, but something regenerative.
Can you explain why you hate using that word?
Because I don't think that it has a presence anymore. I don't think that it resonates with the way that, I think when we talk about sustainability in agriculture right now, we're actually talking about making it less bad. It's not sustainable. It cannot be sustained. When you try to drive something out in perpetuity and you get to absurdity by generation 3, your mouth should be set on fire when you say the word sustainable. So I struggle with that term. So the point is really just that bare soil, which a lot of people look at and think is good, they pick it up and they want to show it to you. They want to smell it and talk about how important it is to what they're doing. Bare soil is losing carbon. It has a photosynthetic capacity of 0. Okay? It can only oxidize carbon. Even though global croplands are currently bare for half of the year, terrestrial soils currently store 4,000 billion tons of carbon. And if you compare that to 360 billion for forest biomes in the above ground biomass, even our most important forests are dwarfed by what we can store in the soil. Healthy biological soil has a 5 times greater capacity to store carbon than the above ground fraction of vegetation. That is the pump that needs to drive it there, but that actually has a very sort of finite capacity to store carbon because it also has a lifespan. And soils that are routinely bare due to cultivation and tillage have half the carbon of the same soils under regenerative practices. And this data up on the slide is data out of Australia, which I think is really important because even in Australia, where drought and fire and tremendous losses of soil carbon, they've been able to show increases that in their drought conditions and in some of the worst agricultural seasons, we're able to increase soil carbon levels by 1 to 3% in very little time. And if that doesn't sound like a lot, it's actually huge in the carbon dioxide war. I mean, that's an additional 1,200 tons of carbon dioxide per acre per year. It's powerful. The other thing that's true about bare soil is that it's losing water. So at least in viticulture, I run up against this all the time. My neighbors come to visit me because they're like, who's this crazy person who's not tilling? What about water? Because I don't irrigate. And I'm always baffled by this question because you can't store water in bare soil. It can only run downhill. And there is a very brief release of whatever moisture is bound up in the roots that were once holding water in the soil, and that can be very temporarily made available to the plant. But otherwise, all that water that you would have otherwise been storing when there's a dew point or something like that, you lose all of that. And at the same time, you're losing soil structure and function. Soil that has organic carbon has 4 to 20 times the capacity to store water as soil that's losing carbon. Those humic compounds are incredibly rich and stable and hygroscopic, so they actually pull water into the root zone and hold it there. That is a critical part of the water cycle that we overlook when we try to make this all about carbon. This is not just about carbon. This is about overall function of all of these cycles. So, like I was saying earlier about plants and how at the species level they support unique suites of microorganisms, they also exude very unique compounds, and that's about the organisms that they're feeding. Complex sugars, enzymes, hormones, nucleic acids, and phenols, just to name a few. But in the micro environment, those are food, signaling molecules, and catalysts for those microorganisms. And those relationships have evolved over millions of years so that plant and microbe alike can respond to very dynamic environments. If you think about when these plants were evolving, it was at some of the hottest temperatures that have ever been seen on Earth while there was life on Earth. And so they are incredibly adaptable, and they have this institutional memory, but we have deselected for those organisms with our practices. So this is really about changing everything about how we think about the agricultural landscape and how we feed the habitats that feed us. An ecosystem, so not a farm, the way that we think of it, but an ecosystem that has a fully developed structure where the thoughtful, functional layers and redundancy within those layers support the balance of a food web, of a real food web, where the maximum energy and output can be attained. That is what our farms need to move towards. We need to remember that we are responsible for these lands. We talk about ourselves as being stewards. We are stewards of these cycles. It is a responsibility. It is not a suggestion. And if you think about the diversity of biological life, not just the plants, but the diversity of biological life that once occupied the savanna-type ecosystems that now are occupied by agriculture, be that sub-Saharan Africa, Australia, and North and South America, those landscapes with zero input supported more life than we can imagine. The diversity of life that existed in those systems without inputs. So we know that we can do more with less. It's not a matter of we're at a carrying capacity that can't be supported. We're just completely dysfunctional. Not to sound too negative. So layered multi.
Can I ask you,
Please.
why? I mean, when you talk about your neighbors who are, tilling and irrigating, and you're not, why are so many farmers of all kinds turning towards those kinds of practices, which are so problematic in all the ways that you're outlining? Why is the incentive there for them to be behaving that way?
I really do believe that this is it comes down to a sociological phenomenon that was very much associated with industrialization and the post-war period, where community was lost for farmers. And that was the onset of the land-grant university system as well, where we started teaching people how to farm. Before that, it was about feeding your family, and so you would naturally produce a diversity of foods and animals and fibers on your farm. After that, farms got much bigger and had inputs put in front of them, and their borders got much wider, and they stopped having the barn raising, and they stopped having the corn shucking, and it became a food system that was outside of community. Farmers are the hardest working, most creative, most resilient group of people that I know, and they have lost each other. So now they fall back on what they're taught in land-grant universities, which is about how to grow one crop in one way. And if you think that there's no consequence for working that way, then it's very easy to see why, somebody would come and see how I'm doing it and say, wow, this looks like a mess. There's so much growing here. I don't know how you can even see what you're focused on. And I think that's really at the heart of it. I know that sounds like a long path, but it really hasn't taken that long. I mean, if you think about places like Russia, where most of the food consumed in Russia is still being grown by the household, that's an even bigger landscape than what we're dealing with. But everything that happened with agriculture in America happened in an instant. And that was about the war. Okay.
Thanks for the detour.
Yes,
Yeah.
No problem. Good. Please stay awake. I'm almost done. So our own evolution, human evolution, very wisely designed a metabolism that preferentially shuttles the nutrients that are needed by our bodies to support metabolism towards those processes of immediate survival and reproductive function. And that's really smart from an evolutionary perspective if you're trying to get the next generation out before you get attacked by like a saber-toothed tiger or a boulder falls on you. But for the modern human being, the way that we're making food now, that has terrible consequences. Because in recent decades, and this is again post-war period, all of the commonly consumed goods, this is in the developing world and the developed world alike, have seen nutrient declines of 10 to 100%. 100% in a lot of cases of even whole foods, but that goes for processed foods, of course. And studies conducted in the 90s showed that, for the 1990 human being, you'd have to eat twice as much meat, 3 times as much fruit, and 4 to 5 times as many vegetables just to get the same level of nutrients that somebody would have gotten in 1940. That is a very brief period of time where we have seen those losses. And so you can really assign that to industrial practices. And we know that, again, that laundry list of postmodern diseases has at the heart of it failures in metabolic function. So 80% of people, and that's probably even a conservative estimate, fail to get minimum levels of minerals and micronutrients that are needed just to support those basic processes of immediate survival and reproductive function. And what that means, and this is the really devastating part, is that everything related to secondary metabolism, which only gets those nutrients after those other processes have been dealt with, that includes supporting things like repairing DNA damage, shuttling calcium into the bones of growing children, immune cell deployment, and certainly, and almost most importantly, as it kind of gets back to the diseases that have really just gotten a whole lot worse in a very short period of time, clearing away dead and senescent cells from tissues like the brain or the liver. These are failures in basic metabolic function that have to do with the fact that we are literally starving to death at our most obese moment in America. Our food has no nutrition. But when diverse perennial cover and a real trophic structure is applied to the farming system, you can see the return of those nutrients in a very short period of time. I mean, what we forget is that these processes really want to happen, and we keep interrupting them, but they keep trying to restart. And so they're just waiting for a little support, and this could all go backwards very quickly. Okay, getting into the deep stuff here. So I hear people say all the time, even really smart and what I think are thoughtful farmers, that plants take from the soil, and so over time, additions of nutrients will be necessary. Like you can't have plants on the soil all the time and not eventually have to put something in. But again, I would just rewind back to the period of time where there was more life being fed by more food and more energy without inputs. So we know that that's not true. And a great body of research is now proving that an agricultural system with diverse permanent cover, so where you're not breaking that cycle by fallowing the ground and exposing the soil to the air, have higher productivity over time than monocultures with synthetic inputs of nitrogen and phosphorus. Not only does that increase the nutrient sort of translation capacity, but it also increases water holding capacity. And as that diversity increases, those effects become quadratic. They're not just, increasing in the same trajectory. They become exponentially more. So rebuilding these things actually would take a lot less time than we think. It's just, scale is a big problem in agriculture right now, and we need to deal with that.
Can you say just briefly, like what kind of time scale do you mean? Like at the level of, say, a vineyard?
Sure.
How quickly does it take to regenerate?
So at my place, which was previously a Christmas tree farm, which is nuclear farming. They don't allow anything to grow under your beautiful, pristine Christmas tree. I can attest to that. And one of the reasons that I focused on Hopewell was because I do not condone the removal of any more habitat in the name of agriculture. I feel like we should be afforesting and rebuilding habitat on the agricultural landscape, doing more with less. And we've seen carbon going up just in a decade. The increases in organic matter, just for example, when we started, our organic matter levels were less than 1%, and we're almost at 10. And that doesn't sound like a lot because I'm used to, at my family's farm, we were able to go from 10 to 12 just with the things that I was doing there.
But still a tenfold increase.
It's a tenfold increase. And not only that, but by doing those things, we've recovered 10 natural springs. And this is in one of the drier regions of the Oregon wine growing area. So a decade, you can, and in terms of growing nutrient dense food, I think that a lot of people have done important work like Dan Kittredge showing that you can do that in one season, just by thoughtful agriculture and really trying to rebuild these nutrient cycles. So rebuilding these systems is really doable. Compost is big. Russ is going to talk about this, and we're limited in time, so I'm not going to drive this to death. But compost is going to be huge in solving these problems, and I think that there's an incredible entrepreneurial opportunity that I wish I could take advantage of in making high quality compost, because a lot of the compost now just has a net carbon footprint actually, and we could be growing beautiful compost that would actually take us a lot of the way there. But what I encourage you to listen to with all of your attention is how animal systems, thoughtful animal systems incorporated in an evolutionary way to mimic the herbivory patterns that would have once occupied these savanna-type landscapes, how that can actually make this happen so much faster. And we have pointed at beef specifically, but animals and agriculture as being enemy number one. And there's a way that these animals could actually be part of the solution, and part of a solution that makes a difference in our children's lifetimes. And that to me is so exciting, and also I think hopeful for those people who are cutting meat out of their diet just because they feel like it's the right thing for the climate. All right, so wine. And I've been accused of this many times. A lot of you who I've met have always been like, so do you want to talk about your wine? And we winemakers focus so much on microorganisms, especially in the winery. Their entire industry is built around microorganisms in the winery and cultivating them and finding the right ones. But we all beat the drum that wine is made in the vineyard. And much of every wine conversation revolves around that sexy French word, terroir. And it really defies translation for a reason, because it is about a much more holistic understanding of place and how place relates to food and community, I think. So the question for the audience, in my mind, is really, does terroir depend on living soil? And there's a reason why I think it was very brave of Doug and Tina and Whitney to take this on, and that's because a lot of wine traditions sort of are at an impasse with what I'm talking about. But because we're an audience that trades in wine, I do want to take a moment just to explain how soil type and soil pH and soil biology relate to the availability of minerals. And I've said this to a lot of people, and I'll say it again, but a root touching a rock does not make a mineral wine. The only ways that minerals can get into the nutritional manifold of a plant is through the microbial pathway. Those microorganisms take inorganic, inaccessible forms of minerals and make them into organic acids and proteins, and then the plant can use them. There is no other way, but there is a sort of unique caveat to that, and I think that it's sort of at the heart of why wine is in a strange territory. So there's one very important viticultural soil that is at the heart of some of our misconceptions about the problems associated with production systems, especially wine production systems. And that's where we encounter the primary oneness of limestone, which is basically the only soil in the world that comes close to a neutral pH. This may get a little scientific, but I think everybody here is fluent enough in basics to understand what I'm talking about. So you can see on this diagram, pH of 7, which is right in the middle of the screen. It's not where that little red line is, but at the pH of 7, most of the critical nutrients and minerals for plants become more available. And that's because at neutral pH, these elements are able to form those compounds without the help of biology. But the other thing that's true is that microorganisms also tend to thrive more at a neutral pH. And so even without the help of plant symbionts, they will exist more naturally, even in a system where it's being repeatedly plowed and left bare for much of the year. When you consider that unique property of limestone, and that many of the world's oldest viticultural soils have been born on limestone soils, long plowed and with no permanent cover, it's easy to see how we could conclude that great wine is married to the plow. But at what cost? Because what I would just suggest that we think about is that even though you can plow limestone and continue to access nutrients as long as there's anything there to plow, you're still losing soil, you're still losing microbiology, and you're still losing your water holding capacity. And so that system is doomed to fail eventually. It just has a longer lifespan because of how limestone is more generous in general. And that is why also most other viticultural soils in the world use agricultural applications of lime to get closer to a neutral pH so that they don't need to depend on biology for that.
Amy, what's the pH, for example, in your vineyard?
So the
and
natural,
how's that shifted over time as well?
Yes, thank you for asking that question. So the natural pH of volcanic soils in Oregon tends to be somewhere closer to 6 or even sub 6. And the pH of our soils when we got there, and this has to do with chemistry and sort of the natural acidic soils of a forest system, were 5.8. And without the application of agricultural lime, and this actually, I'm so glad you asked that question, just with the cover cropping strategies and the use of animal systems in this vineyard, we have increased our pHs to a stable 6.3, which is people will just straight up look me in the face and be like, that's impossible. You got bags of lime stashed somewhere on this property. So, but it's not, because especially, if you think about the way organisms will control their environment by using the minerals that they have accessible to them, you can change your pH just with biology. Okay, so I would, again, just ask, because asking the hard questions, I feel like I have an easier time doing that because I'm one of the people. So does permanent green cover not important on neutral pH soils? Does it not matter anymore? And that really does depend on our beliefs and our values and what we understand is the sort of responsibility of working the land. A belief that wine cannot be great without the plow is a belief, but one that is very quickly thrown into shadow by myriad wines that are created without the plow. I mean, there's, it's a tiny fraction, but there are enough of us now doing, making, I'm not talking about my wines, but I'm talking about other people like François, and anybody knows that those wines are amazing. So wine can be great with the plow, but that's why it's really critical to broaden the questions that we ask ourselves as stewards of the land. And what would it really mean if, as a steward of the land, we were to decide to swear an oath of ethics to incorporate the impacts of any action on the land to all species? And I'm suggesting a sort of decision-making process that would be much more inclusive, and I would argue much more scientific to how agriculture can be a part of a solution. So what is the true line between the plow and wine quality, or even yield? Is it causal? Is it correlative? I mean, do we even know? I think a fundamental question that we really need to look at is for maximum qualitative results for wine, for strawberries, for whatever. Is that practice really necessary? And I would gently suggest that traditions and our very firmly, strongly held aesthetics and traditions are getting in the way of us being able to see the better way forward. There is a path to the fullest realization of terroir that has an ecosystem at its heart. If we remove an ecosystem, what is place? It is only the abiotic parts of that place. And is that interesting? I mean, as a wine, I'm actually asking this question, as a person who loves wine and who has chosen a career in wine, do you want to know how deep that expression could actually be? And another conception that I would beg to question is that if we start growing topsoil on viticultural soils, is that going to be too nutritious for Vitis? I mean, are they going to just explode into a vegetative cycle and not connect with their true terroir anymore? And all I can say is, speaking from my own experience and seeing the work of other people whom I respect and love their wines so much, that natural balance can be achieved, especially by this ancient organism that we, make wine from. Balance is achieved when it is lain down upon a fully functioning ecosystem, and that you don't have to fight vegetative cycles when you're there. We occupy the most erodible, unstable hillsides with viticulture. That's where we've chosen the best sites for growing wine. And we plow them because why? Because weeds? Because aesthetics? It's not because of water. I really hope it's not because of how it looks. On nutrient-poor soils, growing soil actively is a responsibility. I just cannot say that enough times. We could be restabilizing these systems in a way that would allow them to access the true nature of where they're born. In truth, wine and viticulture are really just such a tiny part of this really global crisis that we're talking about, that I think that talking to big agriculture is really important here. But wine is the nexus of food and art, and it has a capacity to open people's minds in a totally different way. It is a visceral communion with an ancient production system that has only survived the millennia because of its beguiling, capacity to tie humanity to the heavens through this earthly thing. And so I think that the sort of infinite ways that wine can express place, like the Bach's Goldberg variations, is something that we're actually missing out on by farming the way that we do. And I'm just going to end by saying that wine growers have always been the leaders of their communities. They have built strong traditions and rebuilt communities, and I think that for that reason we should consider standing in front and questioning our own, conceptions about how we do this the best way to lead the way forward towards the facilitation of this sort of greatest expression of terroir possible. And I do think that it could be our finest hour. If viticulture were to really embrace regenerative practices and stand in front and lead the way for these communities, I don't think that we would see anything other than support, and I think that the wines would also tell that story. Thank you.
Thank you. All right, just ready for some French.
Mm-hmm.
By the way, we're gonna table the question and answer to the end of the presentation. So I'm sure that someone's gonna have some questions for Mimi later. Okay, vas-y.
Welcome to Montlouis, Loire Valley. Sorry, my English is bad. What we Doug will translate. Le domaine François Chidaine a été créé en 1989. Nous pratiquons la biodynamie depuis 20 ans sur l'ensemble du domaine. L'approche bio s'est faite rapidement de 89 à 98 pour aboutir à la biodynamie en 99. Elle a été aussi le début de notre approche dans ce qu'on appelle la conversion des sols.
Just a little history on François Chidaine was created in 1989. What he didn't mention is they have 43 hectares of vines, 20 hectares in the AOC of Montlouis, 10 in Vouvray, and 10 in the AOC of Touraine. And again, it was created they're celebrating their 30th anniversary this year and have been practicing biodynamics for 20 years on the entire estate. And farmed organically in the beginning from 1989 to 1998, and then converted to biodynamics in 1999. That point was also the beginning of our approach of what they call soil conservation.
Nos objectifs étaient multiples. Ainsi, la biodynamie nous a permis de nous recentrer sur les sols, la vigne, le vivant. Cette nouvelle agronomie du domaine nous remettait en cause dans nos fonctionnements, sur l'utilisation des produits de synthèse. Elle nous a permis surtout fait nous interroger sur ce qui se passe dans nos sols, sur le fonctionnement de l'eau, sur le stockage de la matière organique et des oligoéléments, sur la gestion des apports organiques.
So our goals were multiple. Biodynamics refocused our attention on the soil and the vine and really everything living. This new philosophy challenged our previous use of synthetic products and led us to ask a few main questions. Number one, what's really going on in the soils? Number two, what's happening with our water cycle? Number three, is organic matter, namely soil carbon, being stored? And then lastly, how do we manage our organic inputs?
Mais le plus important, c'est d'apprendre à se servir des éléments qu'on appelle la biodiversité. Animale pour la vie des sols, comme les vers de terre, les bactéries, les insectes, etc. Végétale, avec la diversité de plantes déjà présentes sur nos parcelles.
But the most important thing is to learn how to incorporate biodiversity, as Mimi talked about, animals such as earthworms, bacteria, insects, etc., seeding various species keeping in mind the diversity of plants or indigenous plants already present in our plots.
Il est évident que les préparations de la biodynamie y ont contribué, le 500, le mariatune, le 501, les décoctions, les tisanes. Toutefois, pour des raisons suivantes, les préoccupations de François n'étaient pas satisfaites. L'utilisation du cuivre est phytotoxique. Le travail du sol est souvent contre-productif pour la vie et l'équilibre des sols. Érosion, bouleversement des horizons, destruction de la vie des sols, tassement des sols. La monoculture ne permet pas une biodiversité dans nos parcelles de vignes. Ne pas utiliser d'insecticides ni d'acaricides, avoir une meilleure gestion des maladies cryptogamiques, mildiou, idiome, botrytis, etc.
So it is obvious that the biodynamic preparations, the 500, Mariaton, 501, other infusions and tisanes are certainly beneficial. My concern, though, was not satisfied for a few of the following reasons. This is a big one. The use of copper, which is toxic to plants. Interestingly, found out copper is not allowed in Oregon, the use of copper. Plowing is often counterproductive for life and for soil balance. Erosion, disruption of the mycorrhizal network, destruction of the soil life, and also helping soil compaction. Monoculture does not allow biodiversity in our vineyards, and do not use insecticides, and also wanting better management of fungal diseases, mildew, odium, botrytis, etc.
Deux rencontres m'ont beaucoup influencé. La première, la rencontre avec Claude Bourguignon, ingénieur agronome très connu en France, m'a beaucoup apporté. Son regard sur la gestion des sols, sur la gestion des maladies cryptogamiques, nous a fait nous interroger encore plus. Mais il y a aussi mon cousin, Jean-Claude Quillet, l'agriculteur à Montlouis, qui a été un des pionniers en France à se soucier de préserver le potentiel des sols de sa ferme. De par sa nature, curieux et dynamique, il a rencontré Lucien Ségui, ingénieur agronome français qui parcourt le monde en cherchant une préservation totale des sols au travers des couverts et des rotations de culture.
Two people heavily influenced my farming philosophy. Number one, Claude Bourguignon, the well-known French agronomist, whose focus on soil management and the management of fungal diseases made us wonder and even raised even more questions. The second is my cousin Jean-Claude Quillet, who was with us in Oregon a few days ago and here today, is a farmer in Montlouis and one of the pioneers in France to worry about preserving the soil potential of his farm. Thanks to his curious and dynamic nature, he met French agronomist engineer Lucien Ségui, who travels the world seeking a total preservation of soil through cover crops and crop rotation.
Tous ces éléments m'ont amené à observer, à écouter, mais surtout à comprendre comment appliquer cette nouvelle technique dans nos vignes. Mais le plus important était de comprendre les avantages que nous pouvions en retirer pour les sols, pour la vie de nos vignes. La qualité de nos raisins... Ok. Ouais. Ok. La qualité de nos raisins pour avoir la qualité des vins souhaités à travers leur plus pure expression du terroir, de la minéralité, pour le végétal, l'expression du fameux terroir unique à chaque parcelle de vigne.
All these factors led me to observe and to listen, but especially to understand how to apply this technique in our vineyards. The most important thing was to understand the potential benefits for, number one, soil life, number two, the life of our vineyards, and lastly, the quality of our grapes, of course, in order for our wines to have the purest expression of the earth, of the minerality, and the vegetal expression of the famous terroir unique to each parcel of vines.
Je suis parti de l'idée que les diverses variétés céréales, seigle, blé, orge, avoine, Implanté seul en rotation pouvait résoudre mes préoccupations. Il est important de noter qu'un seul pied de céréales déploie entre 200 et 500 km mètres de racines.
I started from the idea that the various and varied cereals, namely rye, wheat, barley, oats, etc., planted in rotation could solve my concerns. One of the most important factors is that a single plant of a cereal spreads between 200 and 500 meters of roots. I had to ask François if that was really true, and it's amazing. Like a single plant spreads that many roots, and the roots can be very, very fine, but it's pretty remarkable.
C'est ça. Donc le début de mes conclusions sur les céréales étaient les suivantes. Meilleure gestion des sols, de l'eau dans les sols, meilleure portance des engins agricoles, une aération plus importante des sols et une gestion plus facile des adventices.
So my conclusions about cereals were, number one, better management of water in the soils, also better bearing of the agricultural machinery, much greater aeration, natural aeration of the soil, and easier management of weeds.
Je trouvais enfin un début à mes interrogations, sachant que chaque céréale en rotation répondait à certains de mes objectifs. Le seigle sur la structuration des sols, l'avoine pour ses qualités allélopathiques, l'orge pour la gestion de la potasse.
So I had finally found a beginning to my questions. Each rotating cereal met some of my goals. Rye for the structuring of soils, oats for their allelopathic qualities, and barley for the management of potassium.
Néanmoins, je suis rapidement aperçu que je n'avais pas vraiment la biodiversité que je souhaitais. Je pratiquais une combinaison de monoculture dans la vigne. Les céréales qui ne laissaient pas beaucoup de place aux plantes endogènes issues du terroir, mais qui ont une réelle activité pour le fonctionnement du sol. Mais aussi la présence d'auxiliaires nécessaires à l'équilibre de la population d'acariens et d'insectes. En effet, les insectes et les acariens sont des partenaires. Ainsi, la diversité de ces populations nous met à l'abri d'une seule espèce dite ravageur. Par exemple, les acariens rouges et jaunes contenus par les typhodromes, ou bien les vers de grappe contenus par les chrysoptes, petites abeilles.
Nevertheless, I quickly realized that I did not really have the biodiversity that I wanted. I was practicing a combination of two monocultures, the vine and the cereals, which did not leave much room for the indigenous plants that are important to the life of the soil and for the presence of necessary populations of mites and insects. Indeed, insects and mites are partners in the diversity, and the diversity of these populations protects us from single species that become a pest. For example, red and yellow mites are controlled by Typhlodromus and wasps, which help then control cluster worms, all pests in vineyards.
Je laissais place aussi aux agressions climatiques des sols, sécheresse, soleil, pluie, gel, pendant les périodes où ces couverts n'étaient plus présents. Ainsi, je reconduisais que partiellement le stockage des matières organiques et les oligoéléments dans les sols, stockage du carbone. Les semis sous couvert m'ont permis de stocker jusqu'à 1000 kg de carbone par an et par hectare. Donc progressivement, nous sommes entrés dans une logique de mixer plantes mellifères, céréales, légumineuses, qui sont souvent les mêmes.
I was missing opportunities to store carbon during periods of climactic soil stress, such as drought, heat, rain, frost, etc. So seeding under cover can store up to 1,000 kilograms of carbon per year per hectare. So gradually, we embraced the philosophy of mixing these plants, these honey plants, these cereals, and these legumes, some of which are the same.
Ok. L'objectif est de ne pas laisser les sols nus tout au long des saisons et que chaque couvert, chaque plante semée puisse jouer son rôle sur les différents terroirs de nos parcelles de vignes, en sachant que les facteurs microclimat, climat millésime, composition des sols vont agir sur la levée ou pas de ces plantes auxiliaires ou endogènes. Elles participent à préserver le potentiel agronomique des sols tout en prélevant le juste nécessaire pour produire des racines de qualité avec une identité terroir profonde, incomparable d'une parcelle à une autre.
The goal is to never have bare soil throughout the season, and that each cover crop, each sown plant, can play its role on the different terroirs of our vines, knowing that the factors of microclimate, vintage, and soil composition encourage the emergence of indigenous plants. They contribute to preserving the agronomic potential of soils while producing quality grapes with a deep and incomparable terroir identity from one plot to another.
Les avantages des céréales offrent une meilleure structuration et aération des sols, un meilleur développement de la vie microbienne et les micro-fissures dans le sol et sous-sol, un meilleur drainage et stockage des eaux de pluie dans les sols et sous-sols, moins d'érosion sans perdre des éléments fins qui sont vecteurs de la qualité des sols, meilleur stockage des oligo-éléments qui rendent une assimilation plus facile de la vigne et une alimentation plus juste, meilleure interaction entre les plantes.
Benefits of cereals. Number one, better structuring of the soil to help encourage aeration, better development of microbial life with the microcracks in the soil and subsoils, better drainage and storage of rainwater in soils and subsoils, less erosion without loss of the fine elements that are vectors of soil quality, better storage of trace elements that make assimilation easier for the vine and provide more nutrients, better interaction as well between the plants.
Les avantages des légumineuses offrent un meilleur stockage, une meilleure restitution de l'azote dans les sols au travers des nodules, azote capté par la plante dans l'air. 78% de l'azote provient de l'atmosphère. Ce sont des bactéries rhizobiennes qui rendent l'azote assimilable par la vigne. Cet azote est de meilleure qualité, naturel, sans apport chimique. Il est nécessaire à la croissance de la vigne et à la naissance de cellules végétatives. Vertus structurantes pour les sols au travers de leurs racinaires très variés, chevelus, tubercules, pivots. Exemple de légumineuses, lotier, minette, trèfle incarnat, pois, trèfle blanc, trèfle souterrain, etc.
The advantages, the benefits of legumes. Number one, better storage and recovery of nitrogen, very important in soils through nodules. Nitrogen captured by the plant in the air, 78% nitrogen in the atmosphere, are rhizobial bacteria that help the nitrogen to assimilate. Nitrogen is of better quality, natural without chemical input. It is necessary for the growth of the vine and the birth of vegetative cells. Also helps us build structure in the soils through their various roots, hairy tubercles and pivots, different types of root structures. Some examples of legumes, trefoil, minette, crimson clover, pea, white clover, and underground clover.
Cette recherche n'est toujours pas terminée et nous ouvre en permanence de nouvelles perspectives, avec l'introduction de nouvelles plantes, voire l'apparition de nouvelles plantes endogènes.
This research is never done, and it constantly opens us up to new perspectives with the introduction of new plants or the appearance, very important as well, of new indigenous plants.
La nature est pleine de ressources, à nous de savoir l'étudier, la comprendre. Les réponses à nos questions sont dans la nature. Osons les chercher, les révéler. Nous devons expérimenter, mais surtout accompagner cette nature.
Nature is full of resources. It's up to us to know how to study it and to understand it. The answers to our questions are in nature. You need to dare to look for them and reveal them. We must experiment, but especially we must always work to accompany nature.
Le réchauffement climatique peut être inversé ou moins stabilisé si ces semis sous couvert sont pratiqués de façon judicieuse à grande échelle mondiale. Nous sommes aussi dans la réflexion de réintroduire des animaux dans nos parcelles de vignes en partenariat avec des agriculteurs éleveurs. Les animaux sont essentiels.
We can help to curb or at least stabilize these carbon emissions if these undercover crops are practiced judiciously on a global scale. We hope to reintroduce animals into our vineyard plots in partnership with other farmers, as Mimi does. Animals are an essential piece of the equation.
Tout reste à réinventer. Le pastoralisme est une voie possible. Thank you very much.
Okay, everything remains to be reinvented. Pastoralism is a possible way of life. Pastoralisme.
Excuse me. All right, I'll try to run through my slides real fast so we have plenty of time for questions at the end. I'm sitting here in awe of two practitioners, and hopefully my presentation will be a little more technical, trying to give you some scientific depth in some of the forces, but you've heard the story. If a meteor hits us right now, you've got the good stuff. So we'll see. But it's an improbable story for many people. The idea that cows can actually help this happen. So back to this pastoral way of life, that the animals, getting them back in ecosystems, and it just so happens that grazing ruminants on grasslands can cover a lot of area really fast. So they turn out to be important. Well, my story, I've only been involved in this for about 6 years. As Whitney said earlier, I spent 30 years taking carbon out of the ground, but it all changed the day when I heard some audacious claims about putting carbon back in the ground, and someone showed me data from a healthy soil, and I recognized the quantity and distribution of that carbon and organic matter in the soil is identical to the source rocks that produce the oil and gas that I'd spent a lifetime sucking out. I mean, all of a sudden it became very real for me that the same processes of photosynthesis that had put the carbon there in the first place could be used to put it back. So this chart is quantitatively representing the same data you saw in Mimi's video. It's from the front side here at the South Pole to the back wall at the North Pole. What it is over time, which is going from left to right, is the carbon dioxide levels in the atmosphere going up and down. It looks like a pump, right? And you see that trend going up all the time. But what I want to draw your attention to is that swing of carbon dioxide in the air in the northern hemisphere is happening because of photosynthesis over land. It's driving it up and down, and hopefully you can see just qualitatively that the swing within a year is actually bigger than the increase year to year. So life is actually a major force that's already doing this every day, every year. And the imbalance on a planetary scale is not as big as you might think if you make life your ally instead of your enemy. So a couple of quantitative charts. Mimi talked about this verbally. On the left, you see a chart where the brown bar is the amount of carbon that's stored in soil, roughly. The green bar is all the carbon that's stored in the biosphere above the soil, and the blue is the carbon that's in the atmosphere. And on that scale, that little tiny red sliver, that's the net total carbon emissions that the IPCC would say, this is the imbalance, this is how much is going out. And you can see it's actually fairly small in the context of the reserves, but it's causing a big problem. This same dynamic of photosynthesis that's pulling the carbon down during the growing season and releasing it during the winter is an ally that we can call upon. The other ally we have is that the surface area of the Earth, the land area, is about a third of the Earth, and about a third of that is used in agriculture. Between cropland and pasture land occupy about a third of the land area of Earth, and pasture land is the largest. So I would argue that one of the opportunities here is the place where humans actively touch that photosynthetic process today is a pretty good chunk of planet Earth. And if we can figure out how to manage that in a way to suck more carbon out of the air, it's a place where there's a potentially very big lever. So the aha to me came at the moment then when I realized that the relationship between a grazing herbivore, a ruminant, and a blade of grass is very similar to the relationship between a bee and a flower. They need each other. They feed on each other. Each requires that the other be there and working in the way it's supposed to for the other to be successful. The reason this is that, I'm just going to go ahead and get everything on here. It's going to be easy. Oops. How do I go back? There we go. Is as Mimi said earlier, a growing plant shares the carbon in the form of sugars through its roots, and it's feeding the microbes. That's in that central pyramid there. They form the base of a food pyramid that goes all the way up through all those other little microorganisms that start the food chain. When a grazing ruminant comes into that system and eats some of that grass, but not all of that grass, and then lets that grass rest, and then takes what it can to run its own metabolism and send the other stuff back to the soil in the form of nutrients, manure, which even organic farmers know is important. What it's doing is helping kind of cycle those nutrients locally in the soil. So you're not having to bring them in on freight cars. The real magic to me, and you'll see a picture here in a few minutes, is those microbes, the bacteria and the fungi that you've heard mentioned a couple of times today. What they're doing is they're acting as an interface with the inorganic minerals in the soil. They're out there mining those nutrients to make it available to the plant. And when this system is functioning, nature doesn't need us in order to capture sunshine. The prairies were here, the forests were here before we were, and it can work really well. So the magic in terms of the process to get this to work right is to go back to grazing our ruminants like they would have naturally existed in the ecosystem thousands and millions of years ago. So in the case of North America, that's grazing bison. And what we kind of did wrong with our ruminant agriculture is we put up fences and we threw animals behind fences and they just start eating and they eat the same thing and they don't let the plant rest. And pretty soon we end up with a degraded ecosystem. What we're learning is that if we mimic that natural system by keeping our animals close together, where they can intensely graze something just right, not too much, and then leave and not come back for a long time, what we do is we create a situation where that cow can fulfill its role like a pump that's pumping carbon out of the air down into the soil. And just to give you some data here now, this is levels of soil organic matter on a number of ranches across the southeastern U.S. where we've measured this. And you can see a nice steady increase. This is very similar to what Mimi said in 10 years. She went from 1 to 10% organic matter in her soil. This is what we see, about a 0.5 to 1% increase per year is very feasible in the system. And those turn out to be really big numbers if you add them up globally. Small concentrations in soil are massive. So the thing I need you to understand here, if you walk away with nothing else, is that this process of photosynthesis and respiration that's going on in planet Earth, as you saw in Mimi's video earlier, if organic matter is going up in the soil, it means that the green arrow, the photosynthesis arrow, is bigger than the red arrow. So you're getting a net CO2 sink. It's really just a mass balance thing. There's no witchcraft or theory or hypothesis or anything. If there's more carbon in the soil tomorrow than there was yesterday, photosynthesis, the green arrow, is doing more work. All right, now what's all that carbon in the soil doing? Well, it's driving this mineral nutrient economy that both François and Mimi talked about. But I want to give you just a little taste of it. To me, the most magical part of these fungi that, as Mimi mentioned, they associate with the plant roots. They will reach out into, this is a slide of what we call a thin section of a soil sample, and that's a grain of sand in there. And those little black lines that you see going through that sand grain, those are tunnels that have been created by mycorrhizal fungi. They're basically chemically drilled their way into that mineral and extracted the nutrients that then it shuttles back to the plant through this complex economy of microbes. et cetera. But that's what biology is doing. It's not just laying still. We're not pumping carbon in the soil to lock it away like gold in Fort Knox. We're pumping carbon into the soil to put it to work, mining soil nutrients. To make this really tangible, if I were a traditional farmer and I saw this slide, I would be horrified, because what you're looking at, primary nutrients of nitrogen, phosphorus, and potassium, and then the one on the right is soluble carbon, is the people in the kind of the grayish bars are all people that are either synthetically or organically paying to add nutrients to their soil seasonally according to the schedule that their extension office has given them and their seed salesman is telling them they need to put down. And this is a soil test of the nutrient levels of those particular nutrients in that soil. The farm on the right is someone who's employing everything you've heard about here today: cover crops, grazing, never tilling the soil. And look at how much this person who has never added a single synthetic nutrient by hand to soil over 10 years has way more nutrients in his soil than the people that have been paying money to add nutrients. Like, this is crazy, right? People would think it's a perpetual motion machine. I gave a talk to NASA one time. I said, this guy doesn't have a nuclear reactor under his soil running this carbon nitrogen cycle that Mimi was talking about. No, what he's got is biology. And by doing this, he's got a system that is more successful. From a business perspective, in the business I'm in, which is beef production, what this means is I grow more grass so I can have more cattle per acre. They're closer together and they move frequently, but in total, I get more productivity. The nourishment in that grass for every bite they take is better, so they perform better. They put on weight faster. So that means lower costs, and I get a better business as a farmer. So just from a practical perspective in farming, this makes more sense once people understand it. This is one of the reasons why a lot of you have come to the room today, is to appreciate what that means for climate and carbon. And I want to just put all kinds of caution. I've got the big yellow sign. I wanted to make it bigger, but then I couldn't fit other stuff on the slide, right? But this is taking a paper that was published last year by Paige Stanley and others at Michigan State University. The red bars you see on the left are the net emissions from the livestock. The green bar is the carbon that's being sunk into the soil. And what you can see is, in the case of this AMP grazing, which is this grazing method that I talked about, adaptive multi-paddock is what it stands for, the green bar is bigger than the red bar, right? So we're getting a bigger sink to the carbon than we're emitting because we're managing in a way that's building carbon in that ecosystem. Again, it's really hard to take a single point and extrapolate it everywhere, but just for the sake of scoping something, if we were able to achieve just that on just U.S. pasture land, we would offset about 20% of the U.S. carbon footprint right there. In terms of comparing to the other levers that we can pull, it's the equivalent of cutting out about 75% of our oil production. It would be the equivalent of taking all of our passenger cars off the road. It would be the equivalent of taking all of our homes off the grid, and it would be more than 7 times the number of wind turbines that we have in service. So it's a big lever, and it could be higher or lower than that, but at least we can see that it's possibly a big lever. Here's a study that was just released a couple of weeks ago. General Mills funded a private consulting company to do a study of white oak pastures, which is someone who's using these methods in Georgia, and compared. They went out and took soil samples and tracked how many animals and how much they emit across the landscape, created a life cycle analysis. And we spend a lot of time going, well, can we do better than regular beef and eat pork and chicken, and kind of synthetic meat alternatives are all the rage right now, or even maybe we just all eat soybeans. But what we can see here is, with this type of protein production, white oak pastures is indeed a net sink, and really that's hard to do. You can make the other ones less bad. Mimi gave that great story on sustainability, but you can't make them more good. By working with biology and nature, you can make something good, a net good to the planet in producing our food.
Which is interesting because beef is considered this huge evil in terms of carbon.
Yeah, and so my little hashtag that you'll see again at the end, some of you might have noticed at the beginning, is it's not the cow, it's the how. Is to really appreciate that it's not the beef, it's how we manage the beef as humans, that's the problem. Now, for geeks like me, I'm real excited about, we're developing some advanced instrumentation that allow us to count this process, little molecules of carbon going in and out of a pasture all day, every day. And what you're looking at here is a chart that's obeying the same convention I had before: red emission, green sink. And this is about a 3-week period. Here, I grabbed it when I made this presentation at the end of April, so it's about the first 3 weeks of April. So it's really when springtime was coming to southern Mississippi, where this particular farm is. And you can, the downstroke is daytime. That's carbon going into the soil during the day and a little bit coming back out at night. But look at how strong and steep that springtime pump is happening over just those 3 weeks. You can basically see more carbon starting to go into the ground again with the return of sunshine. This is what's driving that thing that was going on in the video. All right, really cool. I know you're all amazed, but it is complicated. I don't expect you to remember too much of that, other than maybe it's cool. The good news is nature herself already has indicators that tell us we're on the right track or not. And my favorite now, that I've kind of come into only in the last year or so, is the bird. The bird sits at the top of that food pyramid. It's a predator for a lot of those insects and other things that are growing on the soil. If the carbon is there that's feeding the small things, the big things grow, the birds come back. The birds also like structure in their habitat. They don't like uniform anything in general. So they turn out to be a really good indicator of what's going on. A lot of you may not know this, but grassland and farmland birds are some of the most threatened species on the planet right now. This shouldn't come as a surprise if you think it through, because if you till all the land, take all the life away, spray it with chemicals, make sure that any life that was there is dead and gone now, there's nothing for the birds to eat. And so grassland birds are hugely endangered, according to National Geographic, experiencing a catastrophic decline. So recognizing that, my new friends at the National Audubon Society, this conference was fateful for me. It turned out their headquarters is right down the street, so I was able to stop in and say hi this morning. Have launched a bird-friendly beef production certification system. So grazing beef produced in a way that does good things for birds, also does good things for carbon and water and all the other things you've heard about here today. You're the only people that have seen this. On the right is some preliminary data from a research project that we're in the middle of. Happens to be from the same farm I showed you with that really advanced instrument. We're only halfway through the study. We'll be done this winter. The dark green bar are birds that require grasslands to live. The light green are kind of grassland optional birds, if you will, and the gray bar are other birds. And notice here on the left, where we have a conventional pasture versus the middle bar, which is an ant pasture, what a radical difference this is in terms of bird populations. And even, it's to surprise some of us, and this is just one data point, and again, interim data, we're not really there yet, is that more than the reference prairie system as a whole. And I would argue that's because we've got this natural dynamic life cycle going in there with the ruminants participating as they might have, whereas the reference prairie is, we put it behind a fence and say, don't touch it. So it's really interesting. And we're actually going to start translating that into action. So my company here this summer is working with the National Audubon Society to bring a product to market that's going to try to connect consumers directly to this idea that beef produced, because like you said, most people think that beef and ecosystems, they must be opposite. Well, beef and birds kind of fit in the same category. People don't make that connection, but we think that most people love birds. And if we can reconnect consumers to their food system using birds as a sensor that tells us about healthy food coming from healthy ecosystems, that's third-party certified through the Audubon Society, we think that helps move us in the beef industry in a positive direction. So my story was one of putting carbon back into the ground using cows and grass. And at a high level, we're still looking for the perfect language to push this forward. I think the birds are a really good symbol of this stuff. But I like to say we need to create a renewable food system, because most people don't appreciate that our current food system is not renewable. Mimi gave a passion plea statement for that early on. We just think that because a plant can grow, it must be renewable, but it's not. The story of civilization is one where we've basically used the nutrients that were in the soil before we came along, and it worked great as long as there was some new fresh soil to go to. It ain't going to work anymore. And so we're now in that situation where we have to figure out how to regenerate soil. The good news is every excuse me, ecosystem I've seen, this kind of 10-year thing that Mimi described. So whether you're in any broken system, nature can heal itself really, really fast. The slower variable is here. It's in our brains. It's our ability to employ and learn to think differently, different concepts. Everything you've heard on the stage here today, that's the limiting factor. It's not how fast nature can heal herself. So it's not the cow, it's the how. This is not just about beef. Beef happens to be something that we can touch a lot of landscape with really quickly. It's about learning for us as humans to start working with Mother Earth again.
Thank you.
Thank you.
So I think we've only got about 15 minutes for questions, so I'm going to just ask one. I was going to ask some more, but I think I'm just going to ask one and then open it up to the rest of the audience for your Q&A. But I think just to pick up on something that you were talking about a second ago, the limiting factor being our ability to learn. Mm-hmm. From François and from Mimi, we heard today a lot about how individual, your land as an individual can be really transformed by adapting some of these practices. And you talked a bit about the global impact of what that could look like if we adapted them universally. But what do you guys see as the obstacles to that kind of, globally adopting this much more progressive, much more responsible, much more renewable approach to agriculture?
Maybe I'll start. I'd say that, did I see right that we're like in the same block as WNYC?
Same building.
Mm-hmm.
This building, right?
Yeah.
Yeah, so Science Friday, how many people here are Science Friday fans, right? Great, awesome. And one of my favorite episodes a couple of years ago was a guy from Georgia Tech who invented the backwards bicycle. Does anybody remember that one?
Mm-hmm.
He had to learn how to ride the bike backwards. You turn right, it goes left, and the other way around. That's what this is like to farmers. Everything they thought they knew, that they've been trained at the major universities, our linear mindset is like riding a regular bicycle, and we have to train it to go the other way. It's so counterintuitive to the way we've learned to think about controlling nature that we work with it. Talking to Mimi earlier, she said we need to learn to pay attention to nature, as opposed to, whereas I think where we've come through really since the Enlightenment 500 years ago is how do we control it, conquer it, et cetera. So that's why I said it's all up here. And so it's like the GrassFed Exchange, which is one of the hats I wear. It's farmer-to-farmer education, helping them to teach each other, much like you're doing here today, vintners teaching each other. We don't need, it'd be nice maybe for some other people to do some things, but really we just need to teach each other and to ride the bicycle backwards.
And is that happening at universities now? Are there more progressive?
A few. Well, Michigan State University, I showed you one. A few smaller schools. Shadron State's got a great rangeland thing in my industry. Texas A&M University is picking up. Just had a Skype session with my good friend Dr. Richard Teague there yesterday. But it's they're still the heretics. They're the minority. I think we need farmers to lead and then universities to follow by studying, not the other way around.
Is that basically how you see it?
I would even go farther and say that we need to restructure, if not just eliminate agriculture as a college discipline, where it falls into a very reductionist sort of model of, growing calories. And I think that if the farming community were given the education first in the fundamental physical and chemical laws that drive these cycles, that's kind of all you need to know, and that education is at the heart of it. But I would also add to that I think that scale and the scale of industrial agriculture has got to be dealt with. Some of these concepts are scalable broadly when we're talking about grasslands and mimicking herbivory patterns that would have been natural. But if you think about how much of the agricultural land base is actually now leased to giant companies, and how family farms are becoming less and less, capitalizing on the family farms that still exist and sort of helping the next generation that will be aware of these problems and these solutions, and getting them onto the landscape. I mean, I think there's a major interest, especially in an up-and-coming generation, in being a part of these solutions. They should have access to the land, and that has become almost impossible, especially in America.
All right, so I think it's time for your questions in the audience. Yeah, anyone who wants to ask a question, maybe raise your hand and you'll get a mic brought your way.
Awesome. This is probably for Mimi, but also for François, because everything is complicated when it comes to climate. I'm curious how much you think the ability to start considering no-till is tied to the fact that really within, I'll say 20 years, but probably 10 years, that in many places, especially in France, for the first time, yields and ripeness have actually come to a place where you can reliably get a wine grape crop every year without chaptalization, without having to make amendments. And so in a way, the same complications with climate that are creating a need for reconsidering how we work soil have also finally brought viticulture to a place where it's productive enough that you can sustainably grow a crop every year.
So, just so I know that there's a question there. Okay, yeah.
I mean, essentially, if could we have been talking about no-till 25, 30 years ago? When if you were a vigneron in the Loire, for example, you weren't worried about whether you plowed or not. You were mostly worried about how much Roundup you were using. But but the concern was that you were going to eliminate every bit of competition you could, because the terror was you were going to end up with grapes that didn't hit 19 bricks.
Right. And I think that, again, sort of, I would just point the finger towards the confusion between causal and correlative. And we have, our university systems have been designed to immediately respond, especially from like an extension perspective. But I don't know how this works in France, but I think that we have confused the sort of correlative effects of plowing with the actual causal relationships between integrated plant communities and the way that those facilitate the transfer of nutrients when the plant needs them, as opposed to us thinking that the plant doesn't know what it's doing. The plant doesn't know how to ripen in a trajectory that we think is appropriate, and so we will control every variable that's controllable, and the soil is the first one that we look at. And I think that that's sort of at the heart of where these problems arise. And I agree with you that that is such an entrenched part of our system now that a lot of people have assigned, if you don't do this, then this and this and this will certainly happen. I've seen it happen 100 times in my own vineyard. And again, I would just say, do you know that that is a causal relationship? Because I've been told that it's not possible in my own vineyard, and yet. But I'm sure François.
Maybe wouldn't you almost say the opposite? That maybe 25 years ago, if they had worked your way, they would have had better, more consistent performance in a vineyard.
I do think that there is something to, especially with Vitis, because if you think about, this thing that came like screaming out of the Cretaceous, really ready to take over the world, a vine will grow anywhere, and that it needs to have a complete elimination of competition in order to, achieve appropriate balance. And I would just suggest, especially in Oregon, but I think in other regions where the moisture regimes are very supportive of a vegetative cycle that would arrest itself before it needs to be artificially hedged or something like that, that having a thoughtful and very intentional attention to what's growing on the floor and how those things actually allow the plant to get just what it needs in the moment that it needs it. And I think we cannot possibly imagine that the solution isn't something that we design.
Tu veux ajouter quelque chose? Qu'il y a 25 ans, c'était la formule de la variété de la sol, et c'est pour ça qu'on a un résultat
Qu'aujourd'hui,
Qu'aujourd'hui,
on pratique ça,
ouais.
cette culture.
Et moi, j'ai dit, c'est peut-être l'opposé. Si tu as travaillé comme ça il y a 25 ans, tu pouvais avoir un résultat supérieur.
Ouais, je pense ça,
Ouais.
honnêtement. Ouais. Avec le réchauffement climatique, en fait, en 30 ans, on a avancé les maturités d'un mois. Et je pense que s'il y a 30 ans, on a vu cette possibilité de ne pas travailler les sols, en fait, c'est culturel, on travaille les sols parce que à travers les millénaires, on a toujours travaillé les sols. Et en fait, c'est un bouleversement de fonctionnement, de comportement. Je ne sais pas si tout le monde va comprendre.
Yeah. He's basically, I mean, for 1,000 years, people have been plowing soils, and it's kind of been the way things are done. And he sort of agrees that, with the climate change, that if he had farmed this way 30 years ago, he would have had, better results and better maturity and more consistent maturity in his vineyard.
Et ça nous aurait certainement permis d'aller plus vite, ne serait-ce que sur la non-utilisation des herbicides, de tous les produits qui ont été utilisés dans l'agriculture. Ça me concerne pas puisque c'est pas ma pratique, mais ça aurait fait évoluer tout le monde agricole dans le bon sens pour avoir une meilleure gestion des sols. Ça aurait certainement ralenti le réchauffement climatique, mais le bénéfice, on l'aurait eu quand même sur les raisins. Donc oui, on a perdu du temps, ça c'est sûr. Voilà. C'est aussi toute une remise en cause d'un fonctionnement des millénaires d'agriculture. Et c'est difficile pour un agriculteur de pas labourer les sols parce que c'est presque génétique. À travers la planète, tout le monde travaille le sol parce que c'est la seule technique. En fait, on pense que l'herbe, c'est... Tous les végétaux sont concurrentiels, ils ne permettent pas d'obtenir un rendement, une qualité de raisin, alors que c'est faux. Ce qu'il faut, c'est apprendre à gérer l'ensemble des couverts végétaux pour arriver à un résultat.
Yeah, he was basically saying that it's so ingrained in everyone's head that that's kind of the way you always farmed, and that grass is the great evil, because you're establishing some kind of competition with the crop that you're trying to grow. In this case, a grapevine, when it's actually the opposite. That if you can find out how to have the two living organisms work together, that you actually can make healthier, more beautiful, more terroir-driven, more mineral-driven grapes in this case.
It's the backwards bike.
Mm-hmm.
The backwards bike, exactly.
Who's next?
First, I want to thank you for a truly fascinating discussion and great presentations. Mimi, you touched on this sort of agriculture as really being the property of community and small farms. Are the changes that you all are talking about possible without involving in big agriculture? And if not, how do you approach an industry that seems motivated primarily by whatever is profitable in the short term?
Mm-hmm.
Yes. I mean, it's fairly simple, at least in the beef production side. These people it doesn't really matter what the big chemical companies or seed companies do anymore because they're not using them. So they're not contingent on them in any way. They may have to put up with ridicule or feedback or sense of isolation from when they go to church on Sunday because they're viewed as unusual. But big ag isn't the problem in terms of holding us back from doing something different. There's nothing. I mean, there can be devastating. A friend in Alabama lost a part of their organic garden crop here this last year when the neighbor crop dusting came by with glyphosate and killed everything with overspray on a windy day. So, but those are small bits of collateral damage. We don't need Monsanto's permission to do new things, and we don't need John Deere to invent new tractors.
No, I don't mean. I'm not asking whether they can are interfering with what you're doing,
Can
but
they help?
whether meaningful change can be achieved without involving them in the solution.
No, we definitely want to involve them in the solution. So the research that I pointed to with the bird data is being funded by McDonald's, General Mills. I showed you the life cycle analysis. We want to involve big scale enterprises where they're ready and they kind of get some element that's in it for them. That instrument tower data that I showed you in the data is coming from my former colleagues at Shell. They're investing in this because they now recognize that it's a much bigger lever to pull in the carbon solution than anything they've thought about before. So yeah, I think the big corporations can help accelerate. We don't need, it's kind of the best of both worlds, right? You don't need them to get started, but they can help us scale faster if we can work together and collaborate between small scale farmers and large organizations and companies.
Well, just to ask a totally naive follow-up, Mimi, you were saying earlier that we need to get away from the idea that what we're doing is growing calories.
Right.
Does farming in this way produce less calories per acre, or can it be as productive or more productive?
It's the difference in nutrient density. So a calorie is really about, especially in our food system, is about carbohydrates. And those carbohydrates can be linked to vitamins and minerals or not. It doesn't really change the calorie effect. And so we would certainly, I think, produce the same number of calories, if not more, but with nutritional density. And, my only follow-up to what Russ said is that I think the only potential danger of big ag grabbing a hold of something that is just a purely capitalistic opportunity, especially if there's a carbon economy in the future, that making this only about carbon takes away a lot of the meaning of what regenerative agriculture is really about. And I think that there are, just for example, some of the largest chemical companies have bought up the 3 largest crop data companies in the world and now own all the crop data information. And what that would mean is that they will try to find ways to make money on making this transition. And I think that could be good, but I also can imagine it being horrible in a lot of ways. And I think that the other thing is that while this can certainly be applied on a very broad landscape, as it applies to cereal crops and using animal systems on the massive landscape, when it comes to viticulture, I think there's a problem of scale. And I think there's a problem, if you wanted to talk about the big ag of viticulture, I do think it's difficult the way that we've designed these systems to have them be at the scale that they have achieved. I think that that's very difficult to transition to a regenerative system because they are so dependent on dragging 10 tons at a time for a spray program that has to be repeated every 7 to 10 days. And even if you're growing a really diverse cover crop, the compaction alone is a major problem.
I think we have maybe time for just one more, if back there.
Sorry, I have
Oh,
a mic.
sorry.
I apologize. And I also apologize because I don't have a question, but I'm a journalist who does research in this field. And I think there's been an interesting public and private partnership that just emerged in California called Restore California, which maybe some people have heard about it on the panel. But what it is a friend helped launch it. And participating restaurants in this program, they basically add a 1% charge to their bill, and that money goes directly to initiatives throughout the state that are supporting soil health and building different opportunities for regenerative ag. And actually restaurants can opt in or opt out. Customers can opt out to not have that 1% be charged. But I think that there's opportunities to do that in more states and maybe in Oregon.
Absolutely.
It'll be a while before we see it on the East Coast, I think, but I just wanted to plug that for hospitality crowd.
Yeah, we've actually talked to them quite a bit, or I
Great.
have.
Yeah, I know
Excellent.
Anthony Mint as well, and they're great in leading that program. And I think it's kind of all hands on decks to come up with as many different ways that we can connect with consumers. I showed you the bird-friendly beef thing. The 1% restaurant thing is one thing. We just need as many things as possible in play, and then consolidate our energy behind the ones that really work. This is second or third. I mean, Anthony ran a restaurant in San Francisco, the Perennial, right? That didn't work out for other reasons, but they tried some things there that didn't work as well. And I think we need to get very innovative on a fast time cycle to connect consumers to their food and to ecosystems again.
We have a question in the back.
By the way, I asked François if anyone does anything like that in France, and he immediately said no.
I just wanted to pick up on David's feeling like he was asking a naive question. So I had one to comment that, Russ, you were just saying that the farmers don't need to change their tractors. Can you just break down very quickly about what does it look like for a farmer if they are going to keep cover crops and how that works? So say they're going to be planting corn, that's their crop. What does it look like throughout the year, just quickly? And just to that point, do they not need to change their tractors? Because you hear a lot of pushback on that.
Well, most of the people who have gone back into regenerative grassland agriculture have sold their tractors. And sometimes they'll borrow one. The equipment that's out there already for no-till planting is very frequently used for planting cover crops, and it works just fine. So it's not the place really where the technology needs to be invented in order to do something, or capital to be spent. In fact, usually farmers can sell their tractor and buy some portable electric fencing and a solar charger to, so there's a little bit of a trade-off in that system. So it's the biggest investment in our space, actually, most of the time is in water systems, livestock water systems. We've destroyed a lot of the natural water systems that used to hold water out on landscapes, the beavers, or the engineers that kept small ponds, et cetera. But again, it's all doable and generally affordable, and it's back to that mindset thing that mostly holds us back. So.
And you may be asking, like, if you're a corn farmer or a soybean farmer, what does no-till look like? And I guess the answer is we should probably consider whether or not if we're growing corn and soy for non-human food on a gigantic scale, which could otherwise be grass-fed beef that has integrated, food systems, so where you're maybe you have a small part of your farm that rotates and is devoted to actual food production that feeds human beings. Those are changes, because there is a problem going no-till if corn for animal production systems and feedlots is what feeds your farm, then it's very difficult to transition that to no-till. It's not that it can't be done, but I think it's maybe it shouldn't be done. It should be a different system.
All right, thanks everybody. Thanks everybody on the panel. It's been a great talk. Thanks everybody for coming.
Seconds before you all have to go, I just wanted to say a special thank you to Whitney Schubert. Everything we talk about here, a lot of it is about being a catalyst for change, for movement, for dynamic energy in kind of creating real change, and it has to happen on an individual level, which then spreads to cultures and more people, and it's her interest and catalyst abilities that is one of the main reasons we're all here, and hope we've inspired you, and you can go out and save the world. So.